Hello, guys and girls. The program you are about to hear will be both fun and educational, but it is not a substitute for medical advice. Although we are doctors, we are not your doctors. Hello, and welcome to Travel Medicine. As always, I'm your friendly neighborhood internal medicine doc, Dr. J.
Hey guys, this is Dr. Santhosh, your pediatric infectious disease doc and researcher.
Welcome to Season 9 of the Travel Medicine Podcast. 9 seasons, Santosh. That's almost, a significant number. Because
if I had a nickel for every season, I'd have
we'd
5
have
nickels.
Almost 2 nickels. Oh,
wait. Which is not a lot, but it's weird that it kept happening.
So
that actually fits with this particular instance. I like it.
So let me ask you, Santosh, as we begin Season 9, I'm going to start off with a riddle. And
Okay.
What do sea snails, Egyptian mummies,
Oh, yes.
and Victorian-era Japan all have in common?
Oh, wow. Sea snails, Victorian era Japan, so very early 20th century, late 19th century, and mummies. Is this like a weird episode of SpongeBob SquarePants?
Are you asking if there's some sort of fluke in my riddle?
I'm just, maybe that you're giving me the old runaround here. That you're throwing me a red herring or potentially a red snail.
I wouldn't do that kind of schist to you.
Okay, you're mispronouncing all kinds of words, and I don't know. Do we have to start the recording over? What's the matter with you?
Well, the answer, of course, to my riddle, Santosh, is this week's topic, the beginning of our season, and your favorite, Around the World in 80 Plagues.
Oh, one of these days that's going to be like an actual, like a generated sound bite rather than you just screaming into the microphone.
Home listeners, have you missed us? No?
Yeah.
Too bad. We're back.
If, that's the news opening. For those of you who are too young to remember that, like, the nightly news would have something like that on the radio or on the old TV. But, you can do the news posture when Josh does that. And then when we do our journal club, you got to do your Kermit arms.
For a oral medium, there's a lot of interaction that we're really looking for.
Yeah, it is. We're proud of it.
So what is this new infectious disease that we definitely maybe might have covered in like an earlier season, but I've forgotten about?
Yeah. We've definitely talked about it a bunch here and there because it's not my very, very favorite, eukaryotic pathogen. That, of course, is Toxoplasma, which I study. But it's so bizarre in its life cycle and how does it actually get to a human and start to infect you and that kind of a thing. It's just weird. So, especially when we were talking about traveling to sub-Saharan Africa and Southeast Asia and South America, we've brought these up as causes of fevers of unknown origin or abdominal pain or, little things swimming into your pee-pee.
Ah, yes. Another reason to never go swimming. This public service announcement has been brought to you by the Travel Medicine Podcast. Water, trying to kill you since the dawn of mankind.
It's not true. It's only if you are a little bit irresponsible with where you frolic and you pee in the wrong place in fresh water while you're immersed. But
Schistosomiasis,
yeah.
only infecting people who pee in the river, you filthy animals.
Yeah. Absolutely. I mean, we're glad
So,
it's not everywhere because, dude, the number of people who get like getting in swimming pools and stuff. Oh my gosh.
well, I mean, I don't know. There could be swimming pools, I guess, in sub-Saharan Africa, but I don't imagine they'd stay stocked too long. So let's talk a little bit about the history of this disease before we do the deep dive into pathology and where it is and all of those, because schistosomiasis is an ancient disease, but due to its life cycle, it's considered one of the most important water-based diseases from a global public health perspective. Now, the cradle of schistosomes, that's right, they have their
Yeah.
own cradle,
Yeah.
lies in the region of the African Great Lakes. So let's see, that's Superior, Erie,
No.
Ontario.
No.
Africa has the Lake Michigan?
Yeah. You're on the wrong page. Flip to Africa. This is the kind of the area of the Great Rift Valley, right? There are two continental plates meeting in Africa, and as I can't remember, either come together or pull apart, there's this beautiful, lush, very, very fertile, water-filled jungle area that forms these beautiful waterfalls and rivers and lakes that goes up and down the southern middle of Africa there.
Right. So Lake Victoria, Lake Tanganyika, and Lake Malawi are the African Great Lakes, and it's interestingly an area in which the parasites, their hosts, are both in an active state of evolution and where it may have ended up spreading to Egypt. And we're going to be talking a lot about Egypt. They had, I think by 1920, over 80% of the Egyptian population was infected with it, or at least of the male population.
Yeah. It was actually called, because,
So,
popular, Judeo-Christian literature and everything, the plagues of Egypt. So this was called one of the great plagues of Egypt, the dreadful plagues of Egypt.
and how do you know it's a plague of Egypt? Well, it goes all the way back to the time of the pharaohs. That's right. Remember, my riddle involved ancient Egypt
Yeah.
and mummies, but there is a possible name for schistosomiasis that I'm going to bring up no matter how tenuous the connection, because I just want to say it.
Yeah.
It is in several Egyptian medical papyri, like the Ebers Papyrus, from as early as 1500 years BC, describe a disease characterized by a discharge from the penis known as the disease. Or perhaps it's the disease. Or maybe just the disease.
All right. Because there's no visual medium here, the anglicization from whatever the Egyptian script was is literally three A's in a row,
With dashes between them.
With dashes between them, where the first and last A are longer and the middle one is shorter. So I think more than likely, actually, it's like something like that.
Yeah. Is the sound you make when you're peeing in Egypt.
Yeah. Well, only you gotta only if you pee in the wrong place, like
like the electric fence. So, all right, they don't specifically state all the same symptoms of the disease, but here are some of the important ones. It was characterized by a discharge from the penis, which could also cover kidney stones or a lot of urinary infections. But it's interesting to note that to stop or treat the disease, the ancient Egyptians were encouraged to avoid polluted water. And those who had to make a living in water, such as fishermen, farmers, and others in regular contact, were advised to wear penile sheaths made of linen, which presumably would give you a river condom and stop them from swimming where they shouldn't be swimming. Now, how do we know that this was a disease that occurred relatively often, or at least with some degree of frequency in ancient Egypt. Well, this disease is mentioned 22 times in the
Wow.
medical papyri, suggesting that it came up often enough for people to have to be going back to Wikipedia entries to edit them.
Yeah, this is surprisingly prevalent in this cradle area. And I know you're going to mention other civilizations as well, Josh, but wherever these types of diseases showed up caused by this little worm, this trematode, it it kind of dominated a lot of discussion because of its morbidity. So the problems that it would cause. This one is the urogenital type. We're going to talk coming up about ones that invade your intestines and liver as well.
So, symptoms that resemble schistosomiasis, such as hematuria, which is the genital type, can
Mm-hmm.
also be found in ancient Assyria, where the term was used musu, used to identify any abnormal looking material coming from the urethra or discharge.
Right.
But that word musu was only applied to urine of unusual color or consistency. So it wasn't for any discharge in Assyria, only urinary.
Okay.
And this may even be mentioned in the Bible. Again, not a biblical scholar, so you're going to have to run with me on this.
Okay. Okay.
Uh, Joshua, not me, was ordered to kill a part of the prostitute Rahab and her family, and he cursed the city. And according to the Bible, it seems there was a very strong local belief that any community living in Jericho would produce fewer children than normal. Now, scientifically, this deficit or curse was believed to be associated with infected well water in Jericho. And this is in line with the fact that, at least in the urogenital version of schistosomiasis, it may obstruct the fallopian tubes, end up causing scarring, and decrease the rate of successful pregnancies.
Okay. So a lot like chlamydia could.
Yeah.
Sure.
Um, so let's talk about the people who started discovering this in the way that we know. And I'm very excited because you know how sometimes we go back and talk about one of our heroes, Benjamin Duggar, plant physiologist?
Oh yeah, absolutely. Yeah,
Well,
the famous Benjamin Duggar. Yes.
well, he's not in this episode,
Okay.
but somebody of that same noble line, an Italian physician and botanist. So kind of an early version.
That's fantastic. Okay, cool.
Italian physician and botanist from Republic of Venice, Prospero Alpini,
All right, gotcha.
was appointed to be the physician of essentially the Venetian ambassador to Cairo, and this was in the
Okay.
1500s.
All
So
right.
we've jumped up a bit from ancient Egypt.
Sure. That
Um,
yeah, big gap, but that's okay. Essentially, it was just this disease was recognized and just going on for a super long time in the middle.
well, specifically, it was recognized as going on for a super long time in Egypt, which is what Prospero noticed. He
Okay.
wrote over the course of 3 years, from 1581 to 1584, De Medicina Egyptorium, on the medicine of Egyptians, and he noted a very high incidence of hematuria in Egypt, much higher than in surrounding countries or European ones, 200 years earlier before other Europeans started to comment on it.
Oh, so good observation. Good looking out.
The next time we really see it coming up, and here's where historically it starts getting fascinating. In 1798,
Mhm.
Renaud, a French physician with Napoleon's campaign, also noticed the disease in Egypt, and he actually described, and you can understand at least the rationale when we talk about the symptoms of schistosomiasis in the urogenital tract. He
Right.
described Egypt as the only country where men menstruate.
Oh, okay. So maybe ascribing something different. So not thinking of infection or disease, but almost a natural process of the people who live around here for one reason or another.
He noted that in essentially almost every Egyptian man that they were coming across during these campaigns had at some point during the month
Okay.
urinated blood.
Oh,
He
okay.
drew he drew what he felt was a logical conclusion, meaning who else urinates blood with regularity and doesn't die? And
Got it.
urination is not what's actually happening, but
No, no, yeah.
for the purposes of Renault's intuition. So,
Yes, yeah.
and then he began to notice an obstinate hematuria affecting large numbers of the French troops stationed in Egypt, and particularly the cavalry, where, they would have to piss like racehorses, but
Sure.
bloody.
Sure.
So, frequent urgency to urinate, pain in the bladder, and blood in the urine. Not the entire amount of urine, but the last drops excreted frequently were simply pure blood. And when
Oh,
he began to examine these soldiers, he found inflamed membranes of the bladder compatible with a chronic infection.
okay, okay.
1851, back to Egypt, this time some German parasitologists,
Mhm.
Theodor Maximilian Bilharz. Uh,
I
now
love
that
these names.
now that may have some significance to you because I think an early name for this disease was bilharziosis.
Yes,
Uh,
correct.
and Carl Theodor Ernst first discovered a schistosoma in 1851 during an autopsy performed at Qasr El Aini Hospital in Cairo.
Ye-
Um,
So, meaning they actually saw it microscopically.
yes, he described the emergence of embryos from eggs in the bladder and
Mhm.
their passage in urine to fresh water, as well as this, fluke. So, if we
Yeah.
do some medical etymology, it was named in 1858 based on what the worms looked like under the microscope, and it comes from the union of two Greek words, schistos, that means split, and
Mhm.
soma, that means body. So before we go any further, let's start there, Santosh. What do you mean split body? What do these worms look like? What is their life cycle in general before we talk about their effects on humans?
Yeah, so first of all, the adult worms, okay, when you see them kind of free living before they get to any of the hosts, right? These are parasites. They have to live off of something. And when you see them kind of just migrating around in either the bloodstream, or if you pull them out, in this case, the worms that are actually like coming out of the egg and then they mature, a lot of the time they're these flat, flippy, slippery little tiny microscopic worms. So these aren't the type of big worms that you can see like you just put them in a jar. You really do have to put them under some sort of magnification. But especially when they get to their adult form, and as a for instance in this case, you're seeing it in the bladder, you actually see a male and a female together. They're actually kind of bound together, mating, about to give their eggs out. But in that particular state, okay, when they're entwined together, it's hard to tell whether it's one organism that's cut in half. So imagine taking a ribbon, you just have a ribbon and you cut it lengthwise and you just leave it where it's almost cut but not all the way, so they're kind of wrapped around and curled around each other. You can't really tell if it's like that or if it's two things wrapped around each other. So I can imagine that it looked like it was a flatworm under a microscope, that you would see there were lots of other species of flatworms that were seen, flukes, that's under that big group of flukes, but it looked split. It looked torn apart down the middle. And this is the life cycle that'll give off the eggs. The eggs will come out, and then the one part of the life cycle has to get into snails, okay? And then the snails, house these schistosomes for a while. They replicate, they give off into the water another stage of the life cycle of the worm, the Cercariae. And again, this life cycle, it looks like a flat little wormy thing, but its tail is split. It looks like flukes at the end. And then that thing is the one that can either penetrate skin or get into your urethra, or however, depending on the species, get into a human. And then the cycle starts again where the human incubates it and, et cetera, puts out eggs.
For those of you taxonomy fanatics, it's, I believe, Schistosomia mansoni is carried by the Biomphilaria snail.
Okay.
The Balinus snail carries S. hematobium, and the Oncomalania for S. japonicum.
Yeah, it's so cool. They are very particular about which snail they'll go into. And then the human portion of the life cycle is important for it to turn into an adult fluke and then give off more eggs. So this is a dual host parasite. There are some parts of the life cycle that needs to go through the snail. There's some of it which is excreted, free living, which are the eggs, going into the snail, and then another part of the life cycle that goes into the humans where they become full-fledged adults, and then the humans are giving off more eggs to the thing. So
rents be going up everywhere, and this snail has two homes. Is just born into this kind of privilege. I don't know, man.
It's not fair. Yeah, it gets to live in one home as a juvenile, and then it gets to get out and move into a big old human-sized mansion to become a full-fledged adult and have babies.
Deluxe apartment.
Yeah.
In the bladder or mesentery.
Yeah. Or in your liver. Yeah.
Yeah, so it actually was first discovered in the liver around the 1900s by a Japanese professor, Fujiro Katsurada, who examined a cat and found 32 parasites, because cats are filthy, but including 5 pairs of schistosomes in the portal vein. And he named it, so that is why one of the species carries the name S. japonicum, although it has been pretty much eradicated from Japan in the modern day. Although it used to be known as katayama fever, right, Santhosh?
It was katayama fever for a very, very long time. And I think every now and again, when the patient has the full-blown disease with schistosoma, you're saying japonicum. I think it's japonicum because it's Japan. When they get the full-blown cough, and they've got pulmonary symptoms because of how this thing is migrating, and then abdominal pain, loose pain, tender liver, and the fever and everything. That whole syndrome is called as katayama. I actually don't know what katayama means. It's not named after anybody. I think it actually describes the symptoms of the fever.
Well, Yama is mountain, and kata would be on the side. So,
maybe
side
that's
of
where
mountain.
It was. Oh, God. Oh, so it could be where it was discovered or where it was first described?
I mean, maybe mountain river runoff?
Could be. Oh, that's a good yeah. That's a very, very interesting association. But yeah, the big deal here about what Fujiro did is he was able to associate a schistosome with katayama fever. So
it just comes from the Katayama district of Japan, which is
there we go.
on the side of Mount Fuji. So it is mountainside. I was correct.
Yeah. So yeah, again, like the other physicians in the 1500s and 1800s were describing a syndrome that was unique to a region. This was also a syndrome a little bit unique to a particular region because this is where the schistosomes were flourishing the most. So it was described according to that. But Katayama fever was so called because it would describe all of the symptoms. It would be called schistosomiasis after Fujita Katsurada actually found out, okay, this is the reason why you're getting those symptoms. So he linked together the parasite and the disease.
So these parasites essentially get into you, start making sweet, sweet parasite love,
Yes, yes,
lay
yes,
a bunch of eggs, you poop the eggs out, the eggs then drill into the bodies of snails. The
yes,
snails release waves of forked tail individuals who then penetrate your skin and swim
yes.
up to the sexy time sweets in your liver, heart, lungs,
Yeah,
uh,
exactly.
and it's the circle of life.
Yeah. So the variant on that is what we talked about at the very beginning is instead of penetrating the skin, it'll follow the urine stream underwater. And it'll use that as a kind of way to say, oh, human this way. And instead of penetrating the skin, it'll go up the urethra and then into the bladder, or in some cases for a woman will go through the genital tract, and cause problems in the uterus and fallopian tubes. So yeah, that's just another, a different way to sneak in. It found an alternate route into Casa de U.
Which is part of the reason you shouldn't go swimming, especially in areas with poor sanitation. One of
Yeah,
the most common ways it would be acquired would be school-age children who live in developing areas of the world tend to spend time swimming or bathing in water that contain these infectious cercaria,
right.
the form that's excreted by the snail. And the three main species each have very different regional areas. There's I think around 6 species of Schistosoma,
Yes, correct.
but there's
That
really
infects women.
only three that we see with any kind of regularity, and by we I mean the physicians in those areas. It's not
Sure.
something that you come across too often in the United States
Yes, correct.
yet. Uh,
Yeah.
well, no.
We'll
This
see.
is that's a climate change, not a threat.
It's a climate change. Yeah, absolutely.
It,
So this bug definitely likes warm tropical kind of water. So it's not going to survive very well if there's high salinity, if it's really, really cold. So the Great Lakes in Africa, Josh, unlike the Great Lakes, near Michigan and Wisconsin and that kind of thing, are very, very warm and welcoming to this form of life. It doesn't freeze over in the wintertime.
brag about it, why don't you?
Yeah.
So, S. hematobium is found in Africa and pockets of the Middle East.
Yeah. Huh?
S. mansoni, nothing to do with Charles Manson, but it is pretty useful to remember it, is found primarily across sub-Saharan Africa and South America.
Right.
And, of course, S. japonicum is found mostly in China, the Philippines, and Sulawesi. It's long been eliminated from Japan itself.
Yeah, yeah. Even though that's where it was first kind of discovered, it was probably moved about by humans, or if snails came along, when, we were carrying things in water and, found nice, beautiful tropical waters all along Oceania and Southeast Asia. So made a new home over there.
Now, interestingly, Santosh, modern technology and agricultural techniques
Mhm.
made this disease far worse than it ever was before.
Oh, yeah, yeah. Talk about it.
So, I don't know a whole lot about different irrigation techniques, but I guess the most primitive form is just basin irrigation. You collect a lot of water in some shallow area and then build channels to get it to where you need it to be.
Right.
So in the Nile, you'd have natural Nile flood and cultivating one crop a year. And in areas that were using this basin-style irrigation in Egypt, the prevalence of schistosomiasis was about 5% in the population.
Okay.
But with the development of agriculture and perennial irrigation, meaning you have water coming in all the time, not just when the Nile floods, so upgrading to this modern type of irrigation
Right.
around 1821, the prevalence in the population rose to 60%.
Whoa.
So
Okay.
under 5 to over 60,
That's-
just because you're bringing in all this, fresh water or
right.
non-salinated, non-salted water.
Yep.
in which these tiny little things can survive. And even if you manage to hide from them, you're bringing in the snails that also serve as hosts.
Yeah. So you're basically, because these are irrigation channels, right? So instead of manually hauling water around, you just cut the channels with a, plow or whatever it is so that the river can run off into your field. And, it's not like they're trying to get to you. They're just
Aren't they?
they're no, they're just going to go with the flow. That's all it is so water's flowing that way, and so the snails are going to go that way. The free living, cercaria are going to go that way, and the eggs, which are floating around in the water trying to find a snail host, are all going to kind of go that way. So as you spread out the original reservoir, the schistosomes are going to come along for the ride.
Letting the snails go by, water flowing underground, with the cercaria into your genitals, once in
Or
a lifetime. Well, let's talk about how you diagnose this. Before we had these molecular techniques, we talked about how it was first seen under a microscope. And one of the earliest papers on this by, of course, a British person, because if it wasn't discovered by the British, it doesn't count.
Yeah. Yeah. Well, yeah. I'll say they definitely did help propagate along a lot of this information. Like, wherever they went, yeah, okay, they invaded and it was pretty horrible stuff, but they brought their paperwork along. So,
Yes, thank goodness they brought bureaucracy.
yeah. What would we
So,
have done? Yeah.
in 1910, Mark Armand Ruffer, professor of bacteriology and president of Maritime and Quarantine Council of Alexandria, Egypt,
Mhm.
reported a study on Egyptian mummies of the 20th dynasty. And specifically, he noted that the kidneys of two of the mummies
Yeah.
had microscopic sections, a large number of calcified eggs of what he identified as, remember those two original Germans, those
Yep.
German
Uh-huh.
parasitologists from the 1850s?
Yeah, yeah.
Well, the disease became known as bilharzia, as they were the first to describe it.
Oh,
And
cool.
and Dr. Ruffer, or Professor Ruffer, noted calcified eggs of bilharzia among several mummies. Now, this paper is considered a milestone not because it told us all these other things new about the disease, but it began the entire sub-discipline of paleoparasitology,
I love this.
including the Manchester Egyptian Mummy Project.
Oh, that sounds. I mean, it's basically they're studying mummies in Manchester, England, but it sounds so much more grandiose than that, doesn't it?
I think of like just one mummy that really loves soccer. But in fact, this was the beginning of studying what sort of diseases and bacteria were in mummies and the techniques for dissecting them safely or dissecting them such as to preserve as much of the body as possible. And has now led in the modern day to things like simply doing x-rays or CAT scans of mummies without even having to take them out of their sarcophagi, much less their bandages.
Cool. Yes, yeah. So we learned a ton. We really did. It was a very destructive process, but it was very, very helpful to learn tissue sectioning on these ancient cadavers. Taught us a lot.
And it's something we still do today, although with much less frequency. A study from 1992 used some similar techniques in samples of desiccated skin and brain from 23 mummies from Sudan, or the region formerly known as Nubia,
Okay.
and about 16 of the 23 mummies, so 65% of those mummies, had detectable schistosomiasis eggs.
Oh, and that's the same 60% that you were talking about when they began irrigation, or regular perennial irrigation, like what you were talking about.
So again, as you're developing more modern techniques of civilization. No, the one I was talking about that had it jump in the 1820s was, even more modern. But these are from mummies from Sudan, and even then, it was a very high incidence. We don't know about prevalence, but at least in people who were being mummified,
Yeah.
on average, every other one had this infection.
Well, yeah, you could flip a coin and say,
So, how do you diagnose this disease in the modern day? Let's say you've been out in any body of water in Egypt other than the Dead Sea,
sure, sure.
or freshwater rivers that are in the Caribbean, which actually has a very low incidence of infection. You're more likely to pick it up in sub-Saharan Africa, the Middle East, or parts of South America,
Yeah.
rural Asia.
In the New World, meaning the West, so there's a little bit along the Caribbean, but you'd have to go to the southern edge of the Caribbean, so Belize, Uruguay, I think, and then the northern edge of Brazil. But if you start to get a little too far south and to the wrong waters and stuff, now the parasite really can't thrive very well. So it is quite limited in South America. Like Africa, when you're looking at everything below the Sahara, Schistosomiasis lights up like a Christmas tree. There's so much there.
Usually, the way you detect an infection for this is checking your stool for eggs. You do stool studies.
Yeah, yeah, and they're quite characteristic. You do have to have a good practiced eye. So the folks who look at stool for a living to identify ova and parasites,
Science.
they have to be very, very practiced at seeing sample after sample after sample and using stains to say, oh, that looks like an egg versus, a particle or a fiber or a plant or something like that. It's tough to see if you've never tried it before. But those people who are practiced can like, there's the egg.
Now, if you don't know your shit cold,
yeah.
you can also do a blood test to detect certain kinds of cells that appear when you have parasites known as eosinophils.
Yeah. And we always think of eosinophils as the allergy cell, right? Like the one that gives us the sneezes and everything else when you have pollen or eczema and all this horrible stuff. But back in the days before there were allergies and everything, our eosinophils and histamine and IgE, immunoglobulin E, were all evolved because we have co-evolved with these types of parasites and worms for so long that we have an entire subset of our immune system dedicated to fighting worms.
But you can detect it usually with a stool sample or a blood test, and of course, a good history. You want to know, has somebody been to a part of the world where this disease exists? Have they been swimming or fishing or doing anything that has them for a prolonged period in the water? Because this isn't like the Strongyloides worm that you're walking along the sand and will burrow in. This isn't like some of the others that can get in through the bite of flies or rodents. This is, you need to be in the water in order to acquire it. And it's also not going to happen in chlorinated water. You're really looking in fresh water in the wild.
Mm-hmm. So I decided to go swimming in this pond. I decided to go fishing over here in this lake. And we, basically just hitched up our shorts and waded out into the water kind of a thing and stood out there for, 1 to 2 hours, something like that. And yeah, the cercariae will penetrate your skin. They'll have time in order to do that if you do that, or if you are in the area, the part of the world where Schistosoma hematobium is, then what'll happen over there is you spent long enough of an amount of time in that freshwater lake or river or pond or whatever, and you peed while your penis was immersed. In there, and it doesn't have to be like it's short little like burst of pee. This is really staying in the water a long time and relieving yourself, and that's how you'll get that.
So, what are the symptoms of schistosomiasis?
Oh, I thought you'd never ask.
Well, I
Wait a
mean,
minute.
we are at least halfway. Nope, three
Yeah,
quarters of the way
yeah.
into this episode. I figured it had to come up at some
You
point.
have to come up. So there is one form that we really haven't talked about, which is something called swimmer's itch. Swimmer's itch, Josh. And so there is a type of schistosomiasis, which is by far and away the most common, where they just penetrate into your skin. They don't go any further, and you get these horrible itchy bumps all over after getting out of the water. And those are the cercaria that are actually penetrating into the skin. Some people have a harsh allergic reaction to these with a lot of eosinophils, and it makes it look like hives and scratch, and some people don't. So that's just like the penetration. That's the very, very initial one. Katayama fever, so seen in Japan, but also in swaths of Africa. This one can look like so many other diseases, Josh. So you've got high fever, chills, headaches, nothing to really separate this disease from anything else. But if your eosinophils and your histamine are working, then you might get hives. In the medical term, we call it urticaria. But anybody who's ever had an allergic reaction on their skin, where they have that serpiginous, raised, itchy rash called hives, they can have that. And then the urinary one is exactly like how we've described, where it's like male menstruation. They pee blood, and it can be very painful, and it can look like a lot of other urinary tract infections. Genital schistosomiasis, we talked about, cervical irritation, ulceration, vaginal bleeding, and if it's chronic and not picked up because they're asymptomatic, you can get scarring, which can lead to ectopic pregnancies in the fallopian tubes. The most common by far around the world is going to be intestinal and hepatosplenic disease. So Schistosoma japonicum and Mansoni will go ahead and penetrate, and they will give you then crampy abdominal pain. You can get polyps and stuff in the intestines, which will potentially cause obstruction. But the liver disease is actually quite nonspecific. It can look like a lot of gastroenteritis type of symptoms. So before the liver even gets big and full with all of these, eggs and adult worms and everything else like that, you'll just have loss of appetite, abdominal pain, fevers. And then if it sticks around long enough, the liver will get big, the spleen will get big. And then if it clogs the liver's functions, if you get a really, really high worm burden, what you'll start to get is either jaundice, because you're disrupting the liver's function over there. Or remember how you said, Josh, there were some that crawled into the portal vein? The portal vein is the one that feeds from your liver and gets back into your heart, so that the processed food that goes through your liver, gets back into your circulation. But if that clogs up, there are other veins around it which start to fill up. And so you get varicose veins essentially in your abdomen. So like esophageal varices, and the same type of varicose veins that you would see in like cirrhosis of the liver, for instance, over the abdomen. So that's the typical chronic long-term thing that we see. And unfortunately, as the worms migrate around, they can more rarely, get into your lungs. You start coughing and having those problems, into the central nervous system. And very, very interestingly, Josh, a lot of these worms carry as part of their own microbiome salmonella. So you could have a silent infection going on where you don't have a high worm burden, but you keep getting septic or have urinary tract infections with salmonella. Very, very bizarre. And if you see that as a doctor, you should say, oh, maybe this person has schistosomiasis. You ask them where they've traveled. They said, "Oh yeah, I've been to Democratic Republic of the Congo or Kenya, any place in South Central Africa. Yep, I made the diagnosis. This person has schistosomiasis."
Are there so we talked about some of the long-term effects could be ectopic pregnancies, varicose veins. Is this a disease that can kill you if left untreated? And we're going to talk about treatment in a moment. But is this the kind of disease that can kill you or cause disfiguring or anything beyond what we've already mentioned with increased risk of ectopic pregnancies or not quite sterility, but a much higher difficulty in becoming pregnant?
Yeah, absolutely. So the urinary form, it's not just peeing blood. The bladder, like you said, does get thickened and irritated, and you actually can get just destruction of the bladder over time. And that, of course, your urine starts backing up into your kidneys. And so those folks, before we understood the treatment, those kind of things, they could get septic from chronic or acute urinary tract infections. The genital ones, just like you said, in women, they could get an ectopic pregnancy. It could rupture. They could die. But otherwise, you could have in men as well invasion into the prostate and the seminal vesicles, likewise causing sterility and problems with chronic infections, actually in the scrotum and prostate. The scariest ones are when they get into the liver and into the spleen, so hepatosplenic disease. And this, especially in our children, the worm burden can get high very quickly because their immune systems are not as strong as adult men and women. So here you can overwhelm the liver's ability to function, and you can actually cause bad enough jaundice where a kid can get, encephalopathic from all of the bilirubin and the toxins that the liver is no longer processing, and they can die. Likewise, they can clog up that portal vein, and now all of a sudden you have these bad varices, these filled up veins, which try to supply, back to your heart, but they're stretched and they're very fragile. Those can rupture and a kid can die very suddenly. Likewise, the spleen can rupture and a person can die very suddenly. If they're immunocompromised, so unfortunately, Josh, in this era of HIV, where you have bad immune compromise, then in that case, the worms can just really take over your whole body and replicate to the point where they get to vital organs like your lungs, your heart, your brain, and cause encephalitis. Or one of those instances of salmonella can overwhelm you with sepsis and you could die that way. So it's more commonly in adults, disfiguring, and causes a lot of, I would say, disability. But if you're immunocompromised, if you're young, if you're unlucky, and you have a very high worm burden, then it can kill you.
Now, interestingly, the worms themselves are not what cause the symptoms. And a lot of infections are asymptomatic, as you mentioned. While you can have all these terrible effects, many people are walking around carrying the worms without even being aware of it.
Yep, just pooping out eggs.
And the reason is the symptoms are caused by the body's reaction to the eggs themselves. So when the worm first burrows in, you may see a very slight hypersensitivity reaction in the area the cercaria penetrated.
Yeah, that's the itch. Uh-huh.
Weeks after that original infection, you could get a general hypersensitivity or allergic reaction, especially by S. mansoni or S. japonicum, like fever, cough, abdominal pain, and eosinophilia, which you're not going to walk around knowing you have. That requires a blood test.
Yeah, you need a blood test, yeah.
And then you'll get symptoms. So it is something that, again, taking a good history or really talking to your medical professional about where you've been and what you've noticed and when is going to be key in making this diagnosis or giving the suspicion. But let's say you do have it. How do you treat it?
Yeah, this was just an amazing breakthrough when we were able to get a hold of an antiparasitic that could treat it. Because, Josh, like you talked about eradication in Japan, we could not only take care of individual cases, but just as you were saying, for a lot of people, they're just carrying the adult worms around and just regularly pooping out the eggs, which is a perfect trade-off for this parasite. It's not hurting the host, but the host is still helping it propagate. So now what you have is you've got to get treatment not only to individuals who are sick, but you really want to treat a population in order to eradicate the thing from the reservoir, like the actual, the humans who are carrying it, and maybe the water supply, so that it's not circulating through there as well. So this was discovered, praziquantel, in the 1970s, and this is an antiparasitic. It'll only work on the replicating forms, right? So the ones that are metabolically active. It's not going to work on latent forms like the eggs. So you do have to maybe give it in cycles. But a lot like how we deworm folks, so places where there's Strongyloides cercoralis or Ascaris, these other roundworms, which can cause disability through malnutrition and problems like that, you can actually take a medication like this and give it to a population of folks and teach them then good water, sanitation and hygiene, and you can eradicate this out of an area. So this was one of the, like curing a devastating plague of Egypt. Like this was this level of cure. It was absolutely amazing when it was discovered.
Yeah, so stop defecating and urinating in the river. That's always a
Yeah.
good start. You would think that dosing, a whole population would be very difficult to do in order to successfully clear this, but praziquantel is really only taken for 1 or 2 days to treat the infection. It's meant to kind of paralyze the worm, and again, as you mentioned, Santosh, it only treats the worm, not the eggs. So you
Right.
have to wait for the worms to have grown a bit. So treatment does often happen in cycles, and then steroids are used to treat the inflammatory effects or the allergic reactions itself.
Yeah, so the steroids really are to just control the symptoms, but it's so cool. Just like we can use albendazole or mebendazole in single doses like that in cycles to get rid of roundworm, we can use praziquantel for flukes and trematodes. You go in and you just say, all right, all I need is 2 doses for every single human being here, and I need maybe 2 or 3 cycles of this, so that basically, say I have, hepatic schistosomiasis. I've got my little adult worms partying in my liver, making eggs, and I'm pooping them out. So I take round number 1, and all of the living adults that are partying in my liver go, "Wah!" And they get paralyzed. They don't die, but now my immune system can wrap them up and toss them out and kill them. But there's still some eggs laying around, the ones that I haven't pooped out. So then those eggs hatch and they start to party. And so before they can lay too many eggs, I take my next dose. So that's in a couple of weeks. And boom, I have ended the cycle, as long as I don't go back into that dirty, dirty water until it's been cleaned.
So I guess if there's one takeaway from this episode, it's stop going swimming.
No, stop. The takeaway is proper water control, sanitation usage, and when needed, medication cycles for eradication. You go enjoy yourselves out there, folks. Come on.
Avoid paddling, swimming, and washing in fresh water in these areas. Only swim in the sea or chlorinated pools, which brings up their own host of issues. We're talking about just to avoid schistosomes.
Yeah. And for the places where there's hematobium, Schistosoma hematobium, and this is a good general rule. Just don't piss in the water, please.
Also,
I know,
Boil or filter your water before drinking. The parasites can actually burrow into your lips or mouth if you drink contaminated water. Chew on that for a while, or don't.
Or don't. That's a very good general rule, not just for schistosomes, but for all the other nematodal eggs that might be in there, bacteria, amoeba, all those kind of things that can get you sick. If you get your water up nice to like 212 degrees for at least 5 minutes, you're going to wipe them all out.
And for the TikTok crowd, quickly drying yourself with a towel after getting out of potentially contaminated water is not a reliable way of preventing infection.
Oh, please don't tell me that.
The idea is that because you get these infections after being in infected water for a prolonged time, if you just jump in to, grab something and towel yourself off right quick, poof. You no mas bebes the worms, and I simply want to say it does not matter how fast you towel yourself off. Simply being in the water is enough to be exposed. So that's it for this week.
We had to say that. I'm a little embarrassed at our human species that we had to.
No, look. We've had Tide Pods, we've had bleach. I'm just saying, toweling yourself off, while important, is not going to prevent any diseases.
Yes.
So
correct.
That's it for this week. As always, we'd love to hear your comments, questions, and feedback. You may have noticed commercials on this episode, or if you signed up to support us at $5 a month, you may not. If there were commercials, tell us what you thought. I don't actually know which ones are airing, so
we're hoping that we're not going to be selling you any like pseudoscientific supplements or anything on this channel.
We love to hear your comments, questions, and feedback. The show is produced by me with a lot of help from Dr. Santhosh and friends. Our theme music is composed by Rachel Leisure. Support us, like, review, subscribe wherever your podcasts are downloaded. And until next time, as always, wash your hands, get your flu shots, because we are coming up on flu season.
Oh, yes, yeah. And COVID boosters if you need them.
Get your COVID boosters. If you're in that population that needs it, get your monkeypox shot. Watch for pandemic updates. Tune in every week for a brand new, most of the time, episode on medical stories, histories, and interviews, and enjoy and join us for Season 9 of Travel Medicine Podcast. Until next time, as always, happy travels.
Bye, guys.